The goal here is to find the values of w, x, y, and z, these four angles. We're not giving any measurements here, but we can solve it making a few key observations. So first of all, let's just talk about a couple of basics we need to know here to solve this problem. If you have a circle and you have a tangent line, it's a line that crosses the circle at one point somewhere, anywhere at one point. What's key in this problem is that if you draw a radius, right, to that connecting point right there, that this angle is always a right angle. This is always going to happen, so we know it's going to be 90 degrees. So draw a radius to a tangent line and you get a perpendicular angle. So the radius is always perpendicular to the tangent line, right? And that this is my shorthand notation. I'm not referring to any radius, right? Like this radius right here, I know it doesn't touch the tangent line, but I don't want you confusing it, thinking, oh, if I extend it, it hits the tangent line, it's going to be perpendicular. It's only here at the point of tangency, right, where the radius meets the tangent line. So that's at the point of tangency, right? That's just where they meet. Okay, so that's one key idea. Radius is perpendicular to the tangent line at the point of tangency. The next is a distinction, I think, between central and inscribed angles in circles. So if we have a circle again, and we have a central angle, that's just an angle right at the center of the circle. So here, draw these two radii, I think. And we have angle C for central angle. Well, the central angle always equals the degree measure of the arc it intersects. So if this arc, it's a little bit less than a fourth of a circle, let's say is 80 degrees, right? If the arc is 80 degrees, then the central angle is 80 degrees. That's for central angle. So the central angle is an angle at the center of formed at the center of a circle equals the degree measure of the arc. Degree measure of arc. What's interesting though is, what happens if we have an angle that's not central, and that, like in this case, x plus y. This forms an angle in this circle, but not formed at the center. Well, what happens is wonderful to prove. We're not going to do it here, but the idea is that if here's your center, let's say this is circle D. Well, here if I draw any non-central angle, it's like this one right here, and there are different types, whether or not the center of the circle here is in the middle of the angle or not, right? Well, I'll draw that in 1 second, but here the idea is that this time, if this is little angle, let's say I, right? Because this is called an inscribed angle. What's interesting is that the inscribed angle, no matter where or how you draw it, is always equal to 1/2 of the arc it intercepts, right? So if this has some degree measure I, then this whole length is 2I, or double that, right? So the inscribed angle is always half the arc it intercepts. Here's some quick examples. So example 1, let's say, draw our inscribed angle, and let's label it as being 90 degrees. Well, and you can see this is about, I didn't draw it too well, sorry. This is about half the circle, so it's 180 degrees, the arc. So the arc is twice as large as the inscribed angle. And here's the center of the circle, still circle D we'll call it. But let's just show some other types. Oops. If we have an inscribed angle like this, right? So here the center is outside of the angle. It still works. So it could be inside, outside, or even on the line as well. But either way, this angle, let's say it is, I don't know, 30, right? If this angle is 30 degrees, how long is this arc? Well, the arc's double that, it's 60 degrees, right? So this always works. And that alone is enough to solve this problem. Why? Well, notice these 4 dashes. That means the arcs, right, that they're labeling here, there are 4 of them, are all exactly equal. That's what the dash means. So this, right, and this arc here and this arc are all exactly the same. So those 4 pieces, so we're dividing a circle into 4 pieces. That means each of them must be how big? Well, 360, right, divided by 4 is 90 degrees. So each arc is this large. So this is 90 degrees, and so is this. Now once we have that, that means that x plus y, right, those two angles there, we change colors, x plus y, that's the sum right here of these two, or each one individually, I guess. You know what, I'm sorry, it makes more sense to do each one individually. X is half of 90, so it's 45 degrees. And y is half of the same angle. It's also 45 degrees. Right? Y here, this angle is half of 90. W and Z, it's difficult to label these. W must refer to this chunk though, right? It couldn't refer to the curved circle part because you can't measure that angle, that degree between the line and the circle here. W plus X must equal what? Well, this is a radius here intersecting a tangent line at a point of tangency. So W plus X must equal 90. Therefore, if X is 45, W is also equal to 45, right? Together they add to 90. And the same is true for Z. Z plus Y must also equal 90. So Z is also 45 degrees. All right, hope this helped.